All right, so this is the second video for this ALEKS topic, solving for a reactant in solution. This problem's a little bit more difficult, so if you're struggling with a problem like this, or you don't fully understand this video, because I'm going to go a little bit faster, then watch the previous video to get the groundwork laid. In this problem, we find that we have collected 5.3 milligrams of silver chloride, and that the original sample is 200 milliliters. So that's the information that I really need. There's also some distracting info here. So it says that I add 35 millimolar silver nitrate solution. That's still going to be an excess of silver nitrate. So we really don't care about this. This is just to distract us from the good stuff that we really need. So using this milligrams of silver chloride, I'm going to convert that into grams first. 0.0053 grams of AgCl times 1 mole over 143.318 grams equals 3.698 times 10 to the minus fifth moles of AgCl. And once we have the moles of AgCl, then I'm going to use a mole-to-mole ratio to figure out what the concentration, what the moles of copper chloride are in my sample, right? So 3.698 times 10 to the minus fifth moles of AgCl times, now that mole-to-mole ratio is going to be 1 mole of copper chloride for every 2 moles of AgCl. So in my balanced chemical reaction, we're starting with some copper chloride, and that's what we're looking for essentially. We're going to add excess silver nitrate. That's this excess silver nitrate, again, so this 35 millimolar we don't really care about. We just know that we're putting in enough, so that's an excess. We're going to precipitate out silver chloride. So this silver chloride here, that's what we've precipitated out. So if I know the mass of silver chloride, mass of this precipitate, then I can figure out the moles of that precipitate. Then I'm using the mole-to-mole ratio of 1 to 2 to figure out what my moles of copper chloride are. So that value is 1.849 times 10 to the minus fifth moles of copper chloride. And if I'm looking for my final answer in terms of milligrams per liter, the next step would then be to convert from moles into grams. 1.849 times 10 to the minus fifth moles of copper chloride times, what's my molar mass? 134.45 grams per mole. Gives me 0.002486 grams of copper chloride. So not very many grams of copper chloride. I can convert this grams into milligrams since my final answer is asking in terms of milligrams per liter. So this would equal 2.486 milligrams of copper chloride. And then the final step is just to convert from milligrams to milligrams per liter. So I'm going to take my 2.486 milligrams. This is the actual mass of copper chloride that was dissolved in that original 200 milliliter sample. So 0.200 liters equals 12.4 milligrams per liter. Now, this question says round your answer to 2 significant digits, so I would round this 12.4 to just 12 milligrams per liter. That's my final answer. Now, once you do a problem like this, right, always want to make sure that you can go back through and you can take these words and sort of follow along with the work. Why did I do this? Why did I do this? Why did I do this? If you can answer those questions, you can explain it to someone else. That's a really good indicator that you actually know this. And I would encourage you to practice that.